I need to stop and check something. I may have caused damage.
You what now? That is a real quote from an AI coding agent mid-task talking to the developer who is running it. And if you write code, that is a one-line horror story right there.
The database has been wiped. This is my fault, and I need to tell you immediately. 22 tables. Gone.
Production database wiped by the agent on a task that had nothing to do with deleting absolutely anything in this case. And that's not even the only one. Over the last few months, there's been at least 6 separate verified incidents just like this. Agents leaking private code, getting tricked by malicious files, or just deciding to run a destructive command on their own. I went and read the actual reports, actual GitHub issues, and the actual CVEs, not just the headlines, as much as I could. Stick around because by the end of this, you'll know exactly what to check on your own setup so this doesn't happen to you. A quick bit of context. When you run something like Claude Code, Cursor, or any of your coding agents, you're not just chatting with the model anymore. You're giving it a shell, basically, a real file to access, real terminal access, the ability to run commands on your actual machine. That's what makes them useful. And that's also what makes any mistake or any attacker a lot more expensive than a bad chat response. You can say oops all you want, it doesn't help. One more thing before I get into it. These aren't just this week's news. I'm covering incidents from March through July of this year, 2026. A few months old at this point. I'm not going to bring these up because they just happened. I'm bringing them up because the pattern underneath them hasn't gone away, and it probably won't for the foreseeable future. 6 incidents. 2 different causes. Some of these, someone attacked an agent on purpose, a malicious repo, a poisoned link, a crafted issue, basically. Others, nobody attacked anything. The agent just picked a destructive command in the middle of a completely normal task and nothing stopped it. What you approved does not mean what actually happened. But underneath both, it's the same gap every time. Whether it gets shown to you, the approval box, the log, the task completed message doesn't exactly match what the agent is about to do or just did. That mismatch is the whole story, in my opinion. So let me show you what this looks like in practice. Let's start with the attacker side. There's a report called DuneSlide from a security firm called Kata Networks, and it's about Cursor, one of the more popular coding agents. There's 2 separate bugs, both critical, but the one that I want to walk through is a symlink flaw, and there's a quick definition for this. A symlink is short for symbolic link, that basically a file just is actually a pointer to a different file somewhere else. So you open what looks like the normal file and it quietly redirects you to what it's actually pointing at. Cursor checks whether a file is safe to write by resolving it first. Basically, it's like, where does this actually point before it acts? But if the real resolution fails, let's say the real target doesn't exist yet, or a folder along the way can't be read, it'll fall back to trusting the path as is. I didn't know this before today. An attacker will plant a symlink built to fail that check on purpose. It'll point it at the program that enforces the sandbox, the part of the tool that's supposed to keep it from touching anything outside of your project. And when the right tool follows that symlink out, it'll overwrite the sandbox itself instead. And this isn't only a Cursor problem. A different security firm, Wiz, found the same category of bug across 6 different coding agents: Amazon Q, Claude Code, Augment, Cursor, Google Anti-Gravity, Windsurf. All of them shared one single flaw. The approval prompt that you see is actually fake, in repo looking path, not exactly where the file actually resolves to. You approve what looks like a harmless config edit. What actually happens is a write to your SSH keys, somewhere completely different from what it showed on screen. Side note, Amazon Q and Cursor patched it. They got CVEs assigned. Google fixed it too. However, Augment and Windsurf hasn't fixed it as of the report going public. And Claude Code, interesting one, Anthropic looked at this and said it's outside of the threat model because the developer already chose to trust the folder and approving the edit. I'm not going to tell you who's right here. I just think it's worth knowing that this is the actual disagreement, not a, well, everyone patched it and move on story. Now the other kind. No attacker at all, just an agent, a normal task, a normal day that runs and decides that it wants to break something. My favorite. Back to that quote earlier about 22 tables gone. Developers using Claude Code, their first session with it gives a normal schema and content fix task. About 10 minutes in, the agent runs a database migration, and a part of that migration process involves resetting something called a shadow database. Basically, this is a disposable throwaway copy tool that uses the test the migration safely before touching anything real. Except the parameter pointing at that disposable database was actually pointed at the live production Supabase instance. Prisma, the tool running the migration, resets the shadow database as a part of how it works by design. This is intended. So it did exactly what it was supposed to do, it just did the wrong database. 22 tables wiped. About 130 tools, 21 comparison configs are gone. Some of it wasn't recoverable at all, sadly, because it wasn't even in the older backup set. They did recover most of it, from my understand, from backups, so it wasn't a total loss, which implies how important backups are, let's be honest. The moment you heard at the top, the agent catching itself mid-sentence, I need to stop and check something. I may have caused damage. Then, a beat later, telling developer directly, which, credit where it's due, I guess it did tell them. It didn't hide it. It's basically a toddler walking up and saying, I might have done something. And you can go check the wall, and there's crayon all over it. This one traces back to a Reddit post, and 3 separate outlets picked it up with matching numbers. I went and read the original thread myself to just make sure it wasn't a game of telephone, and it checks out, comments and all. I feel so bad for them. This wasn't the only time it happened. There's a GitHub issue from March, a different app, a lead gen tool this time, where Claude got a warning about a conflict. And instead of asking, it ran a more destructive flag on its own in the background that it hadn't even asked to use. 87 tables dropped, around 200 lead records gone. That is a real outreach data right there. An API spin, 3 days of work, and none of it was recoverable. And a third case, same failure, smaller stakes this time, thankfully, a development database instead of production. 3 separate incidents, same root behavior on every time. The agent hits a destructive option mid-task, and nothing gates it before it runs. So what do you actually do with this? Do you stop using AI agents? Not really an option anymore, not in this world. I use these tools every day myself. The takeaway is closer to don't just trust the summary. Check the thing underneath it. Your AI, your responsibility. So 1, read the resolved path, not the displayed one. When your agent shows you an approval prompt before writing a file, that symlink issue is the reminder here. The path displayed isn't necessarily where the write is actually going. If something feels off, especially in a repo that you didn't write yourself, please check where it actually resolves before you approve. Or just ask it to double check it. You know, you can even prompt the agent directly to verify and show you the resolved path before signing off on anything. Number 2, don't point real infrastructure at safe tooling defaults. The Prisma Shadow database mix-up is avoidable specifically by knowing your tools well enough to know which parameter is the dangerous one, and if a tool has a concept of disposable environment for testing, please actually make sure that it is plugged in every time and not just the first time you set it up. 3, gate destructive commands. Do not rely on asking the agent nicely or them asking you nicely. All 3 database wipes had one thing in common. Nothing forced a confirmation before the destructive command ran. That's a setup problem, in my opinion, more than the agent problem. Permissions and command allow lists exist exactly for this. If you're not comfortable with the possibility of something going wrong, do not run your agent on auto mode. Have it as an assistant. If you can run a schema reset without asking, that's not an agent's fault when it eventually does. You're responsible for what happens inside the permissions that you gave it. 4, treat untrusted text as untrusted even if it's an issue or a comment. So the GitHub one that we talked about earlier, the private repository leak, that one got through because of the model treating the text of a public issue as an instruction instead of just data to read. If your setup lets an action act on text written by someone that you don't know, that's the same shape of risk, whatever platform you are on. None of these 6 needed a genius attacker or a bizarre edge case, a symlink that looks normal, a parameter pointed at the wrong environment, a line of text in a public issue, ordinary looking setups doing exactly what they were told, just not what anyone actually meant. It's a pattern that I keep coming back to on this channel and in real life. What you're shown and what actually happens sometimes isn't the same thing. If you've had an agent do something that you didn't expect, even if it's something small, I would love to hear about it in the comments. And if you have anything useful to mitigate these, please, again, put it in the comments. We are all learning here. AI is just as new and confusing to everybody else. If this was useful, or you think it's useful, you might like my TypeScript to go video that I did right here. I dig into the actual technical reasoning behind the decision that they made, Microsoft, to switch over to Go. So why do TypeScript to Go? You can learn in that video right there. Subscribe if you're into that, and I will see you next time. Bye.